Okay. Okay. So we learn about last class. We learned about capacitor and introduction. What is capacitor? A device that stores charge. Okay, we've seen we have checked the uses of the capacitor last class, and we found that the total charge stored in the capacitor is directly proportional to the voltage applied. Okay, so remember, I just want to highlight here. Okay. Okay. So just one question I come across. So if you have the parallel plate here and you have the battery here, okay, and the electron is moving to the one of the plate here, and the electron accumulate, okay, the electrostatic force between the electron on the left, on the right, and the electron on the left makes the electron on the left to move backward. Okay, move backward. When more electron accumulate here due to the potential here by the battery, more electron, the repulsive force gets stronger. More electron will be moved backward from this plate. Okay, and produces the current flow. Produces the current flow. Okay, and charging. Okay, so the electron from the left plate can't crosses the other plate. No such thing as crossing. So the electron crosses, explode the capacitor spoil. Okay, understand? And the electron accumulate on the right plate. Electrostatic force pushes the electron from the other plate to move backward. So create current. Okay, one question I received. Okay. So today's lesson, what we're going to do is, like last time, resistor connect in parallel and series. We're going to do that to capacitor. Capacitor connect in parallel and series. What happened to the total capacitor? What happened to the voltage across the capacitor? How much is the current flow in each capacitor? So we're going to do that. So capacitor in parallel first. Okay. So capacitor in parallel. Parallel. So you see this diagram. 3 capacitors connected in parallel with a battery. Okay. These capacitors are C1, C2, C3, and carries a charge of Q1, Q2, Q3. Let's say. Okay. For capacitor charge parallel, So for 3 capacitors connected in parallel, of course the voltage is the same. VAB equals to voltage across AB, same as CD here, the second capacitor, same as EF, the third capacitor, is equals to the total voltage V0. Okay, voltage is the same. The second law. So by conservation of charge, total charge Q for the 3 capacitor is charge. Last time resistance for resistance V equals to IR. Now the capacitor is what's the formula for capacitor? This formula, make the V as a subject. So V equals to C over Q. Okay, C over Q. V equals to Q over C. Sorry, Q over C. Q over C. So V, the same location. I replace with charge now. Okay. Last time current. Now in this case for capacitor is charge. You can imagine charge like current. Okay. You can predict your analog charge as current. Okay. That means what I mean analog charge to current is in parallel the current will split, right? The main current, total current. When come to the junction, the current splits, right? So you imagine the charge also the same way. Okay. Like the total charge is here. The total charge equals to the Q1, Q2, and Q3. The charge like split. Okay. So that's why the second equation arises. The Q total equals to Q1 plus Q2 plus Q3. Same like current. Same like current in parallel. Okay. So 3 capacitors in parallel means the total charge stored is Q1 plus Q2 plus Q3. You put more parallel capacitor, more charge will be stored. Okay, charge stored is a lot. Okay, this is the second equation. So from here, Q total is what? Q is what? Q is CV. We know Q is CV. So Q total, you put it as CV naught. Okay, Q total is CV naught. Q1 is C1 V naught. Yeah. Charge stored in one Q1 is equal to capacitance of C1 times the V naught. Actually V1, but V1 is same as V naught. Okay, so C1 V naught, C2 V naught, C3 V naught. Okay, so yeah. So in this case, all the V naught cancels. You get the total capacitance formula. Total capacitance formula. So in parallel, the total capacitance is actually C1 plus C2 plus C3. So just simply add. It's opposite to resistor. Resistor parallel, how do you find the total resistor? 1 over R, 1 over R, 1 over R, right? 1 over R1 plus 1 over R2 plus 1 over R3. But in for capacitor, parallel, simply add C1 plus C2 plus C3. This derivation, you have to know. They'll ask you to derive. How to get C total? You have to derive from voltage. You have to say 1 mark saying voltage same. Second mark, Q is plus. Then replace the Q in terms of CV form. Then cancel all the V, you get the capacitance formula. Okay. So you got an idea. So these the derivations you have to know. Parallel. Okay. Now, for example, one question. Okay. Let's say you have a battery. You have three capacitors. 1, 2, 3, and 3 capacitors connected here. So this is 2 microfarad. This is 4 microfarad. This is 6 microfarad. This is 1. This is 2. This is 3. Okay. So find for me first one total capacitance. Second Q1, Q2, Q3, and the third one, yeah, that's all. It's 3. Okay. So first, C total. What is C total? 1 over, sorry, C total in this case parallel is what? C total is C1 plus C2 plus C3 because parallel. Parallel C total is this. Okay, so C total in this case should be how much? 2 plus 4 plus 6. So it's 12 microfarad. That's the total capacitance here. Okay. The voltage I forgot to give you. Voltage, let's say I give you 10 volt. Yeah. Okay, find the Q1. What is Q1? So what is Q? Q1, C equals to QV. So Q1 is C times V, right? C1 times V1. Okay. So C1 how much? C1 is 2. So put 2. Multiply by V1 how much? V1 is same as 10 volt. 10 volt. So it's 20 microfarad. The charge in 1 is 20 microfarad. So Q2, Q3. Q2 how much? C2 times Q2, 40. 40 microfarad. And Q3 is 2 times, yeah. Sorry, 6 times 10. 60 microfarad. So these are the charge stored in this each capacitor. Okay. Okay. What will happen to these values? What happened to these values? What happened to the C total Q1, Q2, Q3 when another fourth capacitor is added with 10 microfarad? What happened to C total? Drop or rise without calculating? Tell me. Total capacitance will rise. Correct? So the new capacitor is 2 plus 4 plus 6 plus 4. So C total rises. How about Q1? Any change to Q1?
No.
Q1, yeah, Q1, Q2, Q3 never change. The capacitance and the voltage same, the total charge stored never change. Okay. Okay, good. So this is parallel. Okay. So let me erase this. So now we go back to the slide. So now series. Okay. And three capacitors connected in series, one after another. Okay. What quantity is same for this capacitor, for this arrangement? So all
Current.
of current is same. So in this case, charge assumed to be the same. Charge like current here. So first formula, the Q total is Q1 equals to Q2 equals to Q3. The charge stored is the same. So V, of course, according to Kirchhoff's second law, V naught is VAB plus VCD, VED. The voltage is split, added. So V naught, we write V in terms of Q over C1, Q over C2, Q over C3 now. Okay. V naught going to be Q over C, the total Q, total C. So because charge is the same, we cancel all the charge, so you get the total capacitance formula. So in series, total capacitance formula is 1 over C1, 1 over C2, 1 over C3. It's opposite of resistance law. Opposite of resistance. Resistance in series, all added, total resistance. But capacitor is 1 over. Okay. For this derivation, again, you have to remember. The voltages need to be added, make it the total voltage. The charge is the same, so find the capacitance. Yeah. Okay, so we go back to the slide again. So conclusion is for series and parallel for a capacitor connected in series, the V total is what? V1 plus V2 plus V3, and parallel V total is the same like last time for resistor. Current now is charge. Q total for series is Q1 plus Q2 plus Q3, but for series, for parallel, Q total will be, sorry, I made a mistake. Q here same, the same. For series, Q is same, okay? Same current flows anyway, so same charge. For parallel, Q total is Q1 plus Q2 plus Q3. Okay, the last one is something new, capacitor. For series, capacitance is 1 over C total equals to 1 over C1 plus 1 over C2 plus 1 over C3. For parallel, C total is C1 plus C2 plus C3. Okay, so this is the capacitance arranged in series and parallel. Okay, let's do one question about this. Okay. Okay, warm up question first. Okay, one example, let me try to do here. You have 10 volt of battery. You have capacitor like this. Let me go straight away series parallel together. Like this. This is 10 microfarad. This is 20 microfarad. This is 40 microfarad. Okay. So this labeled as 1. This is 2. This is 3. Okay. So find for me, as usual, C total. V1, V2, V3, Q1, Q2, Q3, at any sequence you feel correct. Any sequence. Give all the answer in 3 significant figures. Okay, 1 minute for you. Okay, use these formulas. Try to figure out this question. 1 minute for you. Get all the answers, all 3 significant figures. It's a chain reaction. If the first one wrong, all going to be wrong. So make sure your first one correct. Tell me the C total first. Okay. Okay, I can rub this. Okay, I hope you remember the formulas. the working. Okay. So you got the answer? Hold on. Okay. So first, C total. How much? Is 3SL. So parallel need to be added first, right? Parallel is easy to add. 10, 20, and 40 added is the total capacitance. So how you must do? 20 plus 40 is the total capacitance of 2 and 1. 2 and 3, sorry. 2 and 3. Yeah. So how much you get? Yeah, you get 60. Okay, you get 60. 60. Then the 60 need to be added with 10. So 1 over 60 plus 1 over 10 reciprocal is going to be your C total. Okay, this is your C total. Can anyone help me to calculate? 1 over 60 or 1 over 10 reciprocal? What do you got?
60 over 7, 8.5, 8.6.
8.6, Okay, 8.6. 8.6. Okay, good. 8.6. Okay, microfarad. Okay. Okay, next. Find, okay, now you have to think carefully. Which one can be found first? V1, V2, V3, Q1, Q2, Q3, which is easy to find. Which one you can find first? Yeah?
Q1.
Very good. Q1. Q1. Q1 is the charge stored in the main branch. So I think you find the Q total first. Q total is actually Q1. Q total is Q1. Okay. So Q total is Q1. So Q1 is like, Q total is what? C total times V total, right? Yeah. Okay. So C total how much? 10 times V total is C total is 8.6. So 8.6 times V total is how much? 10. So you get the total charge stored. I think it's 86 microcoulomb. Total charge 86. Okay, good. The first thing if you really understand the derivation just now, first thing you can find is the Q1. Okay. After Q1, what you can find? V1, V2, V3, Q2, Q3. Which one? We know the Q1 already. Okay. What you can find? Anyone? You know Q1? This is same as V equals to IR. If you know the two information, you can find the third one. Okay. So you know Q1. Do you know C1? You know C1. So therefore you can find which one? You can find the V1 first. Okay. So you know Q1 already. Okay, you know Q1. Okay, you know Q1. You know C1. So you can find V1. Next is V1. V1 is what? V1 is Q1 over C1, right? Okay, Q1 over C1. Okay, so Q1 how much? Q1 is 10. Oh, sorry, Q1 is 86 microcoulomb. C1 how much? C1 is 10 microfarad. So therefore 8.6 volt across V1. So next Q1 we can find is V1. The next we can find. Okay. So after V1, what you can find? V2. Can you find V2?
Yeah.
use Kirchhoff second law, the loop, right? The 10 volt is equals to V1 plus V2, right? The Kirchhoff loop rule. So yeah, so 10 volt V1 we know is 8.6, so plus V2, so you can work out the V2. So V2 is how much? 1.4 volt. So V2 is 1.4 volt. So third, we can find the V2. Then we know V3 is also same as V2, so it's 1.4 volt. So V3 also you can find. V2, V3 done. Parallel. Okay, now you can find Q2 and Q3. So Q2 is what? Q2 is C2, V2. We know the voltage and capacitors. You can find the Q2. Q3 also you can find. Q3 is C3, V3. Okay. So C2 how much? C2 is 20 times voltage. How much? Voltage for V2 1.4. Yeah, 1.4. So you get 28. 28, right? Yeah, 28. 28 microcoulomb. The next 3, so 40 times 1.4, so you get 14 times what? 56. 56 microcoulomb. Okay. Okay, so this is how you need to calculate. So it's same as V equals to IR. Same equals to V equals to IR, the same circuit, but now it's capacitor. Capacitor. V equals to C equals to Q over V. So V equals to Q over C to be comparable. V is going to have the same formula for series. Q also going to be identical to I, but the C is going to be the other way around. Only the capacitance formula is opposite to the resistance. In series, resistance all added is the total resistance, but in series for capacitor, all 1 over C added. Okay, any questions from here? Before we move on to another question. Okay, no problem. Okay, stop me if you have any problem. Okay, so I close this. We go back to the slide. Hope everyone get the same number. Okay, let's go to the slide. Okay, so I skip this. This is easy. We go to this question. Yes, okay, this one. 1 minute for you. The next few slides are the answers, but before we go to answers, give a try. 4 capacitors are connected as shown above. What is the potential across each capacitor? How much charge is on each capacitor? So find potential across each capacitor. So they want what is the voltage here? What is V1? V1 to V4. They want V1 to V4. How much? And they want what is Q1 to Q4. How much? Okay. First, before you calculate, you tell me what you will find first. What you will find first. Before you find Q1 to Q4, V1 to V4, you have to find something else first before you can find these 8 unknowns. What is the first one you should find? Anyone? You should find C total. That's the first thing you have to do. Whether they're asking for it or don't asking for it, you have to ask for C total. You have to find for C total first. Then only you can move on. Okay, first find C total. After find C total, you need to find Q total. After you find these 2, you can find these 8, one after another, but not in a whatever sequence you feel proper. Okay, first C total. What is the C total for this circuit? Which one you merge first to find C total? Do you merge, which one you merge first? Actually, this part, this looks scary, the connection, but you can imagine this connection like this. Let me go to the next slide to show you this connection is actually like this. This connection is this. Okay, you see this diagram. Actually, C2, C3 lah. To find C total, you must combine the C2 and C3 first. After that, you combine C1 and C2, 3 together. Then parallel method. Then finally, this C4 and C1 to 3, you add them in series, so you get the total capacitance. Okay, go back. So what is the total capacitance? Anyone? 3 significant here. So first C2 and C3 first to be combined. So C2 and C3 is 90 and 45. So how do you combine C2 and C3? 1 over C total is 1 over C2 plus 1 over C3 and combine. So 1 over 90 plus 1 over 45 will give you 1 over C total. This C total is only C2, 2, 3. I put C2 and 3. C2 and 3. Okay. After you got this, you have to reciprocal. Reciprocal, you get C2 and 3. Then what do you do? The C2, 3 plus with C1. You merge these 3. C1 how much? C1 is 90 again. So whatever answer you got here, that answer you put here, then plus with C1. C1 is 90. So you get now C1, 2, 3. All 3 add up. So you get Y here. Then the Y you add with C4 in a parallel method. In a series method. 1 over Y plus 1 over C4. C4 is 120. You get the total capacity. Okay, so anyone, what's the total capacitance you got? 3 SF. Okay.
So why we need to 1 over Y?
1 over Y.
Why?
1 over 1, which one?
No, I mean why we need to reciprocal Y when we get 90 plus C23.
For the total, is it? For total Y,
Yeah.
C123 is something plus with this is C23 plus C1, right?
Yeah.
You get Y.
Yeah.
So C23 and C1.
Why we add C4 we need to 1 over Y?
Because C4 and C123 is in series. The 1, 2, 3 add up. You see the next slide. You see the 1, 2, 3, the 1, 2, 3, 2, 3 add up, and 1, 2, 3 add up. The C1, 2, 3 and in series. So that's why 1 over Y.
Yeah. Okay, thanks, sir.
Okay. So hope you get C total. The C total I just keep. The answer you should get is where's the C total? Oh, C total not here. That's not a question. Okay. So anyone, what is the C total? Nobody calculating?
60.
60, 60. Okay, C total is 60 microfarad. Okay, so once you got C total, find the Q total. Q total is how to find Q total? Q total is Q. C goes to QV, so Q is CV. So C total, V total, we give you the Q total. So 60 times V total 12 will give you the total charge thought. So how much? 720 microcoulomb. This is the total charge thought. 720 microcoulomb. So the total charge thought is 720 microcoulomb. So Q1 to Q4, V1 to V4, which you can find first? What you can find first? You can find the Q1 first. Because Q1 is same as Q total, right? Main branch one. Q1 is same as the Q total. So Q1 is same as 720. So first you can able to find is Q1 is 720. After Q1, what you can find? Anybody? You found Q1 already. After Q1, what you can find? Q2, can you find? Q2 difficult, it's stuck inside here. I think you have to find the V1 first. V1 is the easiest. So when you know Q1, you can find V1 because you know the two values already. Q1, you know, sorry, this not Q1, this Q4. Q4. So Q4, you know, you can find V4 first. V4. So what is your V4? So V4 is okay. What? C over
Q.
C over Q. C4 over Q4. Okay. C4 is how much? C4 is 120. 120 divided by Q4. Q4 is 720. Will give you the answer. Okay, class. Another one mistake I've done is not 60 microfarad. Should be 60 picofarad. Because all are pico here. So here charge thought also should be picocoulomb. Picocoulomb. So this is 120 divided by 720 gives you the voltage. 120 divided by 720. So what is the voltage you get? Q total. So you got how much? 12 divided by 720. 106, right? 106. Get 106 volt. Okay, let me go back. Oh, you get 6 volt. That is a mistake here. 720.
Q over C.
Oh yeah, sorry. Q over C. The mistake. Q over C. So it should be 720 over 120. So you got 6 volt. Before is Q over C. So you got 6 volt. So here you got 6 volt. So you got Q4, you got V4, you get that volt charge and the voltage here. Okay, after Q4, V4, what you can find?
V1.
V1, very good. You can find V1. After V4, we can find V1. Because of what? Kirchhoff's second law, the closed loop. Okay, V4 and V1 is 12. V1 plus V4 we know is 12. So next you can find is V1. Okay, so how much is the V1? V4 is 6. So V1 also must be 6, right? 6 plus 6 must be 12. Okay, good. So those who know that after Q4, V4, we find V1, that means you are on a correct track, V1. So why V1 is 6 volt? After V1, what you can find?
Q1.
After V1, you can find Q1, correct? V1. You can find Q1. Okay, find the Q1 for me. V1, you know, C1, you know, can you find Q1? Okay. C equals to Q over V. Find Q1. So Q1 is, you know, V1. So Q1 is C1 V1 lah. C1 times V1. C1 is how much? C1 is 90. So 90 times C1 times V1. V1 is 6. So it's 540 picocoulomb. 540 picocoulomb. That's your Q1. Check the Q1. Yeah, 540 picocoulomb. 6 volt, 120 picofarad. Yeah, 720 picocoulombs, 540 picocoulomb. Okay. So go back. Okay, so after you got C1, V1, what you can find? What is left is the V2, V3, and Q2, Q3. Which one you can find? V2 and V3, can you find? V2, V3? Yeah. You can find Q2, right? Q2 and Q3 same. Okay. Q4, you know Q4 is 720. The main branch is 720 Q4. Split into two. Q1 how much? Q1 just now we found is 540. So 720. One branch go 540. Another branch will be how much? So what is your Q3 and Q2 will be? 720 minus 540 lah, right? Okay. So you see this branch. This is your main charge, Q720 main branch charge. Here is 540. So the one charge flows here is 720 minus 540. So 180 is your Q3 and Q2. Q3, Q2 series. So this must be the same charge term. Okay. So once you know these two charge, you know this capacitance, you can find volt over that two capacitor already. Okay. So this is one question about capacitor in series and parallel together. You must know any capacitor questions. First thing you must find is C total first. Then you find the Q total. Then other sequence you have to figure out. Any questions? I believe those who are tried got these all values. Okay. First thing you need to find is the total capacitance. Total charge is the 720 is the first. Then 6 volt for the Q4, C4. Then we can proceed the others. Okay. Okay. So before we continue with energy, another one question. Okay, you have one battery which is 12 volt. Okay, and you have a capacitor here, 20 microfarad, and you have another one which is 40 microfarad. Okay, 20 microfarad, 40 microfarad. Okay, both as safety voltage of 6 volt. 6 volt. Both as a safety voltage of 6 volt. So that means you give more than 6 volt, you're going to explode. Okay. Sorry, this is not 12 volt. So more than 6 volt, you're going to explode. Okay. So now this voltage, this battery is a variable voltage. Like your, the voltage can be raised. We can raise the voltage. When V is raised, okay, when V is raised, which capacitor will blow first? V is just continuously raised. Which capacitor will blow first? The 20 microfarad or the 40 microfarad? Both has a safety voltage of 6 volt. Which will blow first? Okay, 1 or 2. How to find which is going to blow first? Which is going to utilize more voltage? The small capacitance or the big capacitance going to utilize more voltage at one particular time? Who is going to use more voltage? Last time, you fix two resistor in series. Okay, you have a battery, R1 and R2. Okay, R1 is 2 ohm, R2 is 4 ohm. Who will use more voltage? 2 ohm or 4 ohm? Definitely big resistance. 4 ohm will use big voltage, right? More greater the resistance, more greater the voltage it utilizes. Okay, for resistance. But for capacitor, it's the other way around. Which going to use a big voltage? The small capacitors will use a big voltage. 20 microfarad will use a big voltage because of what? C equals to Q over V. Okay, Q equals to CV. Both at any moment going to store the same charge. Okay, same charge. So same charge. Both store the same charge. So that means C1 V1 must be same as C2 V2. Okay, C2 V2. So C1 is 20 microfarad, 20 microfarad. C2 is the 40 microfarad. So from here you can find, you can see that what when C1 is smaller, the V1 definitely is greater than V2. Okay. So who's going to blow first? And the voltage is rises, the 20 microfarad will blow first. Okay, 20 microfarad will blow first. Why? Because smaller capacitance uses big voltage. So the 20 microfarad will achieve 6 volt earlier. Okay, will achieve 6 volt earlier. Okay, now the question is, okay, 20 microfarad going to blow first. At what is the V max maximum voltage you can apply here so that both capacitor can work without blowing? What is the V max value required so that these two capacitor is working properly without blowing? Okay, 1 minute for you. Come on, give a try. V max required. V max required. So what is the V max required? The maximum voltage. You rise the voltage until both can work without blowing. If you go slightly a little higher than this V max, one of the 20 microfarad will blow. Okay, what is the V max required? So how do you find V max? V max is actually same as we know is same as V1 plus the V2 because they are in series one. Okay. When V is max, you know one of the voltage of these two. You know V1 and V2. One of the V1 or V2 you know. Which one you know already? Confirm. Which one you know uses how much? The V1 definitely going to be 6 volt. V1 definitely will be 6 volt because 20 microfarad achieve 6 volt earlier than the 40, right? Because small capacitance going to reach big voltage. You're going to always take a big voltage. Okay, when you rise this voltage up, the 20 microfarad will achieve the 6 volt first. Okay, and the 20 microfarad achieve 6 volt. Okay, then that's where the V max is achieved. To find the V max, you need to find the V2. When V1 uses 6 volt, V2 is how much? When V1 is 6 volt, V2 will be how much? So how do you find? So by using this formula, right? So C1 is how much? C1 is 20 microfarad times 6 volt should be equals to 40 microfarad, 40 times the V2, the new V2. So you can find the V2. So V2 is how much? 3 volt. 3 volt, right? Yes, 3 volt. So V2 is 3 volt. So its answer is 9 volt. Okay. The Vmax required to prevent both of them work properly without blowing is 6 volt. So how do you get the 6 volt? First, you must identify which will achieve the peak first. So one of them you must write it as 6 because here the capacity of the voltage will be given to you. This 6 volt, this 6 volt. So if this achieves 6 volt, you find this will achieve how much? Because charge is same. From the charge same, C1 V1 same as C2 V2, you can find the V2. Then you can find the Vmax. This one famous question they ask in capacitor. What is the Vmax to be used? Which going to blow first? This kind of questions. Okay, any part you don't understand here? Okay, can okay, so I move back. Okay, so that's capacitor in series and parallel. Capacitor in series and parallel. Okay, next, what we're going to talk about is energy stored in a capacitor. Okay, of course, energy stored in the capacitor due to the charges are separated. Okay, there is one year they asked how capacitors store energy. How can what causes the capacitor to store energy? The answer is the energy stored by the capacitor by doing work by doing work to separate the charges. Okay, to separate the work done to separate the charges is stored as energy. Okay, for example, you can imagine like let me let this. You can imagine, let's say, in your hand you have a big sphere which is positively charged, and you have another hand, right hand, you have a big sphere with a negatively charged. You are holding it. You know, both of them are attracted. Okay, so when you move this sphere away, okay, what happened? You do work. You do work, right? Work has been done because you are pushing this side. You are applying a force. You have traveled a distance of d, so you did work, force on d. Okay, so now the charges are one positive here, one negative is quite further away. Work has been done by you to separate the charges. When you let it go, this will move back. You are attracted to the positive, so create current. Current is produced. Okay, this mechanism applied for the capacitor. How capacitors store charge? By work done to separate the charges. The charges has been separated. Okay, so work done to separate the charges is stored as energy in the capacitor. So remember, work done to separate the charges is stored as energy in the capacitor. Okay, so now a charged capacitor store electrical energy is equivalent to the work done for depositing Q charge on its plate. Okay, you see here, when the battery releases a charge of Q, okay, when a battery releases a charge of Q, okay, the charge of Q, releases the charge QE. Okay, this is the charge it releases, and this is the V. Okay, when it releases a certain amount of charge, Q total, the voltage of the battery is going to be constant. The voltage of the battery is always constant, never drops. For a battery, voltage never drops. We assume never drops. So the area in the graph is the energy stored, energy released by the battery. So work done is QE, Q times V. Voltage is constant. Okay, from definition of voltage is work done per unit charge. Okay, but when this energy transferred to capacitor, how the V versus Q graph looks like for a capacitor? Is it a flat line? When the charge stored, the voltage of the capacitor rises. The voltage of the capacitor rises like linearly, because C equals to what? C equals to Q over V, right? Q over V. Capacitor is constant. Capacitance is constant. So the Q over V or V over Q, the gradient must be constant. So it must be a straight line with a constant gradient. So you see here, when the total charge released by the battery is in square, the Q total, but capacitor store the Q total charge in its plate. But you see, the energy stored in capacitor is how many V? How much? The area in the graph. How much the area in the graph here? Is half QV only. You see, the area is triangle. It's triangle. So area in the graph is the energy stored. So half QV is the energy stored in the capacitor. But energy released from the battery is QV. You now tell me, what is the efficiency to store energy in the capacitor in this case? How many percent? What is the efficiency? So the battery release energy of QV, but the capacitor store charge half QV. So the efficiency is only 50%. Okay, 50% of efficiency. Any energy stored in the capacitor, 50% of energy will be lost in the heating of the connecting wire. Only 50% will be stored in the capacitor. Okay, so formula for energy stored in the capacitor, something new, half QV. Okay, now you know C equals to Q over V. Okay, you throw out the C, you throw out the Q, you substitute as CV, you get half CV square. Okay, and you substitute the V from the first formula, substitute the V as Q over C, you get the third formula, half Q squared over C. So these are the three energy formulas for a capacitor. Okay, class. So this is the today's class. I don't want to track further. Any question up to here? So no question, eh? Okay, one example, last example for today. Find the charge and energy stored by a 1000 microfarad capacitor when the potential across it is 6 volt. So how much is energy stored for 1000 microfarad and the voltage across the capacitor is 6 volt? So in your mind, you must have three formulas: half QV, half CV squared, half Q squared over C. This is the energy formulas. So in this case, which formula do you use? 1, 2, or 3? Check the availability of the information. You have C, you have V, so you have to use the second one, half CV squared to be used. Okay. So the solution is the charge. You can choose the charge, or you can use half CV squared. Half CV squared, energy is 18 millijoule, and it's okay, and it's 6 volt, so it's 72 millijoule. You see, the voltage double, the energy stored is 4 times greater. Okay, stored in the capacitor. Okay, class. So, any questions up to here? We spend another one class to finish this topic. Then we go to the next topic. Okay, so as homework, please go through these examples at the back, PowerPoint, get ready. Okay, I done with the topic already. So the next slide, we're going to go through the balance slide. Any questions?
Sir,
Yeah.
I not yet received my exam registration form.
What form is it?
Exam registration form.
Exam registration form. Okay, let me check. Oh yeah, they sent me. I sent to you later.
Okay.
Okay, class. See you then. Bye.
Bye.